Top microservice anti-patterns. Here, the common anti-patterns and how to avoid them. A well-built microservices architecture-based application can withstand the test of time by being scalable, flexible, and resilient to most issues that may come its way. These architectures achieve a high level of resilience due to its loosely coupled components that can run independently, therefore not being affected by other microservices within the application. This being said, there are always ways that a microservice architecture can fail and become ineffective. In this article, we will look into some of the most common anti-patterns or design patterns that can bring out issues within a microservice-based architecture. Monolith in microservices. If you're trying to build microservice while preserving a monolith architecture, you'll run into issues with scalability, fault tolerance, and many more. This is often caused by shared databases. When you're building microservices, it's often a good idea to have a database per service. This lets you control the database type, schema rules, IOPS capacity on a per-service rule, thus letting you have finer control over scaling. But if you use a single database for all your service, you make it harder for your app to grow. Complex deployment. Despite being decomposed into smaller services, the deployment process is still complicated and time-consuming, requiring coordination between various teams and manual involvement. This limits the agility and flexibility achieved by implementing microservices. Inadequate service boundaries. Poorly specified service boundaries would result in overlapping functionality and unclear ownership. This can lead to duplication of work and difficulties in controlling and improving the architecture. So to avoid having monoliths in microservices, I'd recommend going ahead with a single database per microservices, along with defining clear ownership of your microservices via a domain-driven design. Chatty microservices. Due to their decoupled nature, microservices often communicate with each other to process the workload of the application. While communication is key, over-communication or inefficient chatter between microservices will make them less efficient. Let's look at some scenarios that can significantly decrease efficiency while contributing to chatty microservices. Frequent inter-service communication, cases in which microservices within the system send a large number of requests to other microservices to accomplish minor tasks or obtain small amounts of data. This can generate large network traffic and increase response delay. Fine-grained APIs. Microservices provide fine-grained APIs that require numerous calls to complete a single user request or business transaction. Each call may need serialization, network overhead, and even blocking I/O operations, increasing performance issues.